For this video, we're going to be graphing two variable inequalities. So we're going to have x's and y's in them. So let's just use this worksheet, and we're going to start with number 1 here. We've got y is less than negative 2x plus 5. So when we start this, the first thing we're going to do is we're just going to graph the function as though it were an equal to. So we're just going to plot those points. So for this graph, we have a y-intercept of 5. And a slope of negative 2. So I'm going to go down 2, 1 to the right. I'm going to fill my graph the whole way by plotting my points. I also, from my original y-intercept point, could have gone up 2 and 1 to the left. Now the difference comes when it's time to connect the dots. So what I have is just a less than symbol. There's no equal to symbol. So when I connect, I'm going to connect with a dashed line. Oops, I went a little crooked at the end. I added up at the top that I'm connecting with a dashed line because what we have is a less than or a greater than. We would use a solid line for a less than or equal to or a greater than or equal to. So in number 2, I have less than or equal to. That's going to be a solid line in this picture. All right, so let's go to the next part. We have to say that y can be anything that is less than this function. If we're talking in terms of y first, less than would be the downward direction for y. So I'm going to pick any point on my curve. I'm going to pick the point I started with, and I'm going to go down, and I'm going to shade that. I could do this for every single point that I plotted. I can shade down, and essentially what I see happening here is I'm shading this whole part of the graph. Everything below the dashed line I drew. You don't have to blacken it in completely, but you should show that that's the part that's shaded. All right, and what does this mean? This is the solution. In the past, our solutions were things like x equals 5. Well, we've shaded a whole bunch of solutions, and what this means is if I were to pick a point, like this blue point I just plotted right in the middle, the coordinates of that point right there are negative 3, 1. If something's a solution to an equation, it means that it makes the equation true. If we're a solution to an inequality, it means we make the inequality true. So this is an xy ordered pair. If we went back up to our original problem and we plugged in a 1 for y, a negative 3 for x, and then we evaluated, is this a true statement? Is 1 less than the right side? Well, the right side would be negative 2 times negative 3, which is 6, plus 5, which is 11. So is 1 less than 11? Yes, it is. So I plotted that as a solution. And essentially, all of these things over here that are underneath the graph are all solutions. They don't just have to be integers. They could be all the points in between. And when I start plotting everything, I have a graph that looks like it's shaded. All right. Why don't you pause the video and try number 2. On this one, I plotted my line y equals 2/3 x plus 1. I connected the dots with a solid line because I had an equal to part down here in my inequality. Now this was a less than. Again, I pick any point on my curve or my line, and I go down because less than is down in a y direction, and this is what I'm shading. I'm shading everything below my line, and that whole thing is the solution. I never added the words up the top for what I'm doing, so I'll do that now. So I picked any point on my line or curve, we'll do curve soon, and for y is less than or y is less than or equal to, I need to shade down. If it's y is greater than or y is greater than or equal to, I need to shade up. All right, let's look at number 3 here. Number 3 isn't a line. This is a graph of an absolute value function. So I need to graph my v. My v has been scooched 1 to the right because there's a -1 on the inside, and down 4 because there's a -4 on the outside. My v has a slope of 1, so I'm just going to plot some points, up 1 over 1 and up 1, 1 to the left on the other side. Then I need to decide how I'm going to connect my dots. Well, I had a greater than or equal to. It's the equal to part down there on the bottom that tells me I need to draw a solid V instead of a dashed V. Next, I need to decide, do I want to shade the top or the bottom of the graph? Greater than, y is greater than. The greater y direction would be up. So I pick any point on my curve or line and I go up from there. So this is the part of the graph that I'm shading, and I'm just going to shade all over everything up here. Doesn't matter what quadrant we're in, everywhere above that V gets shaded. All of the points in the shaded region would make this inequality true. I'll do one more with you, and then I'll let you pause while you try the rest. All right, the next one is a quadratic because it has a squared. So that's going to be a U shape. There's a +3 inside, so I've scooted 3 to the left. The shape for a U is 1 squared is 1, so I go over 1 up 1 in both sides. 2 squared is 4, so from my anchor point over 2 up 4. 3 squared is 9, so from my anchor point I go over 3 up 9. Now it's time to connect my dots. This is just a less than. There's no equal to, so when I connect my curve here, I need to make a dashed curve. Sometimes it can be hard to tell when you guys do these, so it's nice if you just write dashed to give your teacher a clue that it was supposed to be dashed. Or if it were over here, you could write solid to tell the teacher your line was actually connected. All right, now we're trying to decide which way to shade. Since this was a less than, I pick any point on the curve and I go down from there because less than in the y direction is down. That means I'm shading down. Now over here I'm also shaded because any of these points are in the same region. So the whole outside of this U shape is being shaded because it's all down from some point on the curve. Okay, go ahead and pause the video while you try number 5 and 6. After you try 5 and 6, you can check your answers. And pause the video again while you do the next two. And we'll keep going with that method. If you need more time, leave the video paused while you check. Okay, here are 5 and 6. Pause the video if you need to look at them longer. All right, here's 7, 8, 9, and 10. Now you notice 7 is a little different because it's just y equals 5, which was just a plain old horizontal line. So you can see when we graphed on there, we were just horizontal. There was no x, so the slope was 0, 0x. And then we shaded up. Now in number 9, we have just an x. So when we're doing an x equals line, if we have x equals a number, it's just a vertical line because the x values of all the points have to be that number. I made it dashed. And then less than and greater than, I don't have an up or a down here, but with x, you know less than is on the left and greater than is on the right. You can also look at number 10. If you need more time, pause the video. Here are 11 and 12. If you have any questions, come into them next class.